Hey there, I'm Kevin O'Connor, a solutions engineer here at HashiCorp, and today I'll be taking you through an overview and demo of HCP Packer and why some of our most successful customers use the platform for multi-cloud image management. All right, so let's get a little hands-on. It's usually the best way to learn, and we'll start with some of the basics, right? So I think we know, the majority of cloud deployments out there use Terraform, right? Our infrastructure is code tooling to deploy infrastructure, right? But a key question then comes about is, how does Terraform actually know what to deploy, right? We could say, let's deploy 10 virtual machines, but then what should the specifications of those VMs look like, right? Like what operating systems, apps or programs should be installed on those machines, really to support our workload, right? And when we're talking about VMs and containers, it's usually an image which is used for the deployment, right? Which you can think of as kind of a template that defines all the parameters of that server or VM or container or whatever it is that you're going to deploy. In the case of AWS here, right, those are what are known as Amazon Machine Images or AMIs. And if you were to go ahead and launch an instance just straight from the console, they're going to give you some what they call quick start AMIs that you can use for the basis for that deployment of the VM. At a high level, they really just contain the operating system, and then maybe some of the virtualized hardware that's going to come along, with that VM is going to be based on, right? But more likely than not, right, your organization is going to have sort of specific needs in regards to, the source code and maybe some security tooling and additional configuration that's going to need to be included in that VM. So what you're going to have to do is use some sort of a tool to kind of build and compose that image, right? In the case of AWS, they have the EC2 image builder to create custom images, right? But we'll go through this real quick, right? They give you some high-level options like, hey, is this going to be used for a VM or a container? What operating system do you want this to be to use, right? And then as we scroll down, you can start to see that, it gets a little more complex, right? So they start asking you about, what sort of components do you want included within the image itself, right? If you want this to be able to be monitored by AWS CloudWatch, well, you're probably going to need a CloudWatch agent on it, right? Or if, let's say, you're going to be deploying a Java application for a web server environment, right? Maybe you're going to need Apache Tomcat on there, or if you were building a Microsoft Windows workload that was based on the .NET framework, right? And you needed the .NET runtime to be included within your build, well, then, that'll have to be a component that's included within the image as well too, right? Just a few examples here to sort of give you an idea of like what components could be, right? But there could be additional, security tools, agents for external monitoring systems or SIMs, right? That you want integrated, a whole number of things, right? And they can really be layered on top of one another and start to create a lot of complexity when it comes to, the requirements that are needed for your organization to successfully run their applications. So let's say we get all that bundled up together and we're ready to publish or sort of build that image. Well, you're going to need some place to put it, right? In Amazon's case, they have the catalog for AMIs. We go ahead and publish our image to the catalog here, and we can start to see maybe there's a little confusion already sort of rearing its head here, right? So what's the real difference between this second and third image here, right? They look very similar. Is it just sort of the timestamp on the end? Okay, now if I'm an operator that's coming in here, right? These may be images that are shared with me by the rest of the organization. How do I know which one I should be deploying? Is it the latest one? Okay, great. Maybe I'll just use the latest one. But wait a second, maybe that hasn't yet been blessed by the InfoSec team, and they're actually in the process of reviewing it, right? Or maybe I should be using the latest one because a previous version, there's a known vulnerability that's come out for a certain component that was baked into that image. Okay, so now I'm a little confused as an operator as to which one it is that I should be deploying, right? Now try to imagine managing all of this, right? We're just talking about AWS here, but now multiply this by Azure and Google Cloud and on-prem, right? And if I'm supposed to have sort of a standard template and process around what it is that should be able to be deployed within my organization, I'm going to run into some trouble, right? And there's going to be a lot of inconsistency across the board when it comes to my images. So enter HCP Packer, right? Just do a quick kind of overview whiteboard before we jump into a demo. So Packer, as many of you may know, has long been there's been a community version of Packer that's out there, right? And where that comes, what comes into play with that is you have your Packer file, similar to like a Terraform configuration file, where you specify all the inputs, maybe your source code, config management, tooling, additional security compliance controls, whatever it may be. You feed that into Packer, you run a Packer build, and then you get your image, right? So this is kind of Packer in a nutshell, and Packer community more specifically in a nutshell, right? Where we might be then sort of creating, AMIs for Amazon environments, maybe VMs for Azure or, VMware. We might create containers, for Docker containers to run on a container platform. So Packer can generate all different types of machine images and artifacts for the different platforms we run on. But the challenge comes at this point, right? It kind of alludes to what I was talking about before. How do we go about managing all this sort of stuff, right? And this is where HCP Packer comes into play, because maybe we have our AMIs in the AWS catalog, but maybe we're using Artifactory for our VMs, and then we're using the Docker registry for our containers. And now we're managing 3 different systems and trying to have standardization across all of them, right? And how do we sort of manage the metadata across all of those systems as well? Ultimately, we want to make this easy for the users, right? We want the user experience to be easy, and we want them to be able to come in and say, hey, what's the latest version of this artifact or image? And that's what I want to be able to deploy. So let's take a case in point, right? Let's say this is actually our base OS, right? We're building a hardened image. Maybe we do it every month. Well, we run it through Packer. We're then able to publish it into the Packer registry, right? Cloud hosted by us, HCP Packer, right? Comes in at the end of the pipeline there. And we can then publish our base OS, and we'll call this version 1, into the registry. So we have a bucket for that. And then we have iterations for the different platforms that we're running, or where we want to be able to run base OS. Great. So we have got an AMI and a VM. And then, we're able to sort of programmatically feed this into downstream systems, right? Let's say all of these have kind of unique identifiers. Maybe there's an AMI ID or an Azure VM ID, right? And as you can imagine, as many of you may do already, maybe you feed this into Terraform or consume it as part of an Ansible script, or even as part of a different Packer run, right? You may be asking, well, why would I do it as part of a different Packer run? And I think, in reality, we're not just going to be deploying base OS images, right? We're actually going to be deploying web apps, right? So we have, let's say another pipeline for our web app here. And we're going to be defining, the same sorts of inputs that we were before, but we're not going to be starting from 0 this time, right? We are going to be using base OS as the starting point for our web app, right? So our base OS image is the starting point for our web app image. And then we can re-execute Packer, and we're going to get all of the outputs for the types of images that it is that we want to deploy. And then we can go ahead and publish that as well, too, into the Packer registry, along with the different iterations for the different platforms where it is we're going to be deploying this. Now we're ready to deploy it and kind of call this out in our Terraform code, right? So we feed this into Terraform, and we say, give me the latest version of web app, right? Using tags that we've kind of applied in the Packer registry, we can decouple our code so we don't have to hard code or string along specific, identifiers, or worry about calling out, individual variables everywhere in our code. Not to mention, when we start versioning and coming out with newer versions of these images, having to then go about and change those parameters everywhere it's called out in our code, right? We can simply say, in this case, we have a resource block for an EC2 image where we're saying, the AMI is going to equal our data block up here. And in the data block, we're just saying, give me the latest version of web A, right? Or web app, right? And that's going to look for the latest version within the Packer registry. And that's what's going to be used as the basis for our deployment. So again, we don't have to worry about the AMI IDs, or how do we, saving the variable every time, a new build takes place, or anything like that, right? And so with kind of chaining this all together, the power of it all really starts to come into play, in 2 different areas. The first is when we think about version upgrades, right? So let's say there's a new version of our operating system, it's Patch Tuesday, we're doing our monthly patching, whatever it may be, right? And we want to kind of harden our base OS. So we go about and we now build version 2 of our base OS. Well, this allows us to come in and sort of re-execute our second pipeline in an automated way, right? Where that pipeline is now going to pick up version 2 of our base OS and redeploy our web app into version 2 based on, the now more recently hardened version 2 of our base operating system, hardened image, right? And now when we go ahead and re-execute Terraform, right, without changing any of our code, because we've sort of decoupled the images from our code, right, it's going to pick up the newest image and deploy version 2 of our web app automatically, right? So we have that kind of end-to-end flow in terms of, how do we go about, image building and versioning those things. And we may have multiple layers that need to be built on top of one another. And how does that all get chained through to the final deployment, right? Now, a key property as well is that the Packer registry will maintain sort of metadata of what parent builds these were baked on, right? So we know that version 2 of our web app is built on version 2 of base OS, and version 1 of web app is built on, version 1 of our base OS as well too, right? And where this starts to come in handy is when we think about security, right? So let's say that in fact version 1 now has a known vulnerability that's been out there, right? And we no longer want people to be able to deploy version 1 of our base OS, or any image that was built on top of version 1, we don't want to be deployed, right? So we can come in and essentially revoke the ability to deploy version 1 of our base OS. And that's going to chain through and actually identify that version 1 of our web app was built on version 1 of our base OS as well too. And that's going to be revoked, right? We're no longer going to give people the ability to deploy that, right? So now if someone was to come in, let's say, calling out in our code, instead of calling for latest, they were calling for the tag of version 1, right? Maybe that's some team that's wants to see how, other teams operate on a more recent version, right? Before then upgrading themselves, right? They call out version 1 within their code. Well, when they go to execute Terraform, that's going to get flagged, right? It's basically going to say error, you're trying to deploy a revoked image, right? So we have that's all kind of been changed through, and we have a sort of a policy guardrail check within Terraform Cloud that basically asserts like, hey, you're trying to deploy a version that's been revoked, right? So we start to see this sort of end-to-end provenance, right? Where we can connect basically the underlying images to the actual application images that are being built, all the way through to the infrastructure that's being deployed and managed, right? And so it not only helps us do sort of automated rebuilds when we think about versioning and baking in upgrades on top of those versions, but it really gives us a workflow around how we want to manage security, specifically with the ability to revoke images, and how do we enforce that all the way through to the infrastructure that's being defined, right? So we can start to define sort of policy checks that restrict, our ability to modify or deploy, net new applications with revoked images. So let's take a quick look at what this looks like in practice. So I've got a Terraform run here in HCP Terraform. You can see we have our plan and apply workflow, and something in here called a post plan, which is a run task integration I integrated with HCP Packer. We can say we've got a failure here. We actually have an app server that was trying to use a revoked image, right? And it basically tells us that version 1 has been revoked, but there's a newer version available. So I'll need to go ahead and, find that newer version in HCP Packer and update my code. And then it's also telling us with these two down here that HCP Packer does not track the artifact, does not track the image that's being used for the deployment of that app server and this web server, which is a huge red flag, right? We don't want anyone to just be able to go in and deploy whatever it is they want to, right? We want to have some standardization and consistency and enforce people to deploy only approved images, right? So that's very powerful in and of itself. And when we look at HCP Packer here, we can see we have some buckets with our images. In this case, we're looking at learn Packer run tasks. And we can see we have multiple versions of that image, right? And here I was trying to deploy version 1, which has been revoked. And there's the newer version, version 2, which should be used, right? So hopefully that's helpful. Touches on a bit of the basics of image management and images, some of the challenges that are associated with that. And then, kind of going into the differences between, Packer community and what HCP Packer brings to the table. Right? But really, we're looking to give your organization a way to comprehensively manage images, and the solution that HashiCorp Cloud Platform brings and provides to really help your organization become more efficient and secure. Thanks so much.